Alright, right now we're dealing with standard 11 collisions. We have car traveling east and car traveling the south. In the east direction, this car weighs 1,500 kilograms, traveling at 17 meters per second. In the south, we have a car of 1,800 kilograms, traveling at a pace of 15 meters per second. We need to figure out the velocity of the cars right after the collision, and then we need to figure out how much kinetic energy was conserved to another during the collision. Okay, here is the momentum of the car in the east, the momentum of the car in the south. Okay, so I'm going to use both of these. Okay, you add 15 plus 18, add those two up, you're going to get 3,300 kilograms, and we're using V cosine theta. Alright, V cosine theta, get it by itself, divide 1,500 kilograms, divided by 3,300 kilograms, answer above, multiply by 17 meters per second, you get 7.73 meters per second. That's the car traveling east. Car traveling in the south, the momentum of it in the south, you do pretty much a similar thing, but we're using the sine of theta. Okay, I get my answer, 33 kilograms, multiply by the sine of theta, separate it, 1,800 kilograms divided by 3,300 kilograms, multiply by 15 meters per second, 8.2 meters per second. Now to figure out the velocity the car is traveling, I'm going to do the square root of this and use the car in the east and the car in the south. Take two answers, square them, do the square root, and the velocity is now 11.27 meters per second. Now we need to figure out the angle they were traveling in. Okay, so I'm going to use tan of theta equals the sine and the cosine. Okay, taking the sine of what we just received, 8.2 meters per second, right here from the car traveling in the south, and the 7.73 meters per second, car traveling in the east. Okay, get tangent theta equals 1.06. Do the inverse of tan, you get 46.7 degrees, and that's angle in the southeast. Now we need to figure out how much kinetic energy was conserved to another during the collision. The initial, kinetic final. Alright, what I would do here is a half multiplied by 1,500 kilograms multiplied by 17 meters per second squared plus 18 kilograms times 15 meters per second squared. I'm going to get 419,205 joules. Okay. Now, solve for the final. You are going to have to do a half, open parentheses, 1,500 plus 1,800 times 11.27 meters per second squared. The 11.27 is coming from the velocity of the car, the answer on A. Okay. Now you add these up, multiply them, and it is going to be 209,571.285 joules. Subtract both of these, and subtract the initial minus the final, and I'm going to get 209,678.715 joules. That's it. Thank you.